their life. Okay. Mm, mm, Excuse me. wait.
Okay. All right. No questions about this. Clear. Good. Um, for me, it gets all twisted when I rotate it. Then something is getting mixed up somewhere. And I don't know what could be wrong. It's possible that it's very easy to accidentally use mixed values. Like if you're doing the dot product between a local space vector and a world space vector, you're gonna get weird results. Weird, incorrect things will happen. So quite often, when you get those types of weird, just you move something and something else moves in a different.
Yeah. So fuck. Assignment. So we were here. No, right here.
Different direction, or you rotate something and something else is just pivoting off of somewhere else. Usually you're mixing up local coordinates and world coordinates somewhere. So I would double check that, like make sure all of your math is done in the same space. I think that would be the first thing I would check. Okay. All right. So far we've just been doing the drawing itself. We haven't done any of the like actual trigger itself. We've just been very helpfully making gizmos so that whoever is sitting and doing level design or whatever can see what's going on, which is very good. Crucial thing in tool development, which is something I spend a lot of time on. All right. So we have our angular threshold, we have our pi, it's in local space, everything's great, except the fact that it doesn't work. It doesn't do anything. It just looks pretty. So the next step is to do the math to actually detect whether or not something is inside or outside.
I have a script. Where is this? New where was this one? I have a script for it. Where it is? Reserve local to world, math logic, math, yes. Where to local to place down. trigger. It was a trigger. Trigger. Use different consumers. It was a trigger, right? Okay. Yeah, this is the one. Right. So we are getting the center. Okay. Okay. This trigger is false. Void. Okay, distance. Distance is equal to vector 3. Distance census in position. Vector 3 player distance p1 equal to transform dot position. Vector 3 delta player distance void. If the distance is greater than equal to the radius, yeah, this one. Now we just have to put like we have to follow this one right here. We have to like make a trigger condition, then we have to like ask if the trigger is true, then we have to like turn on our laser if our trigger is false, then we don't have to turn on our laser. We don't have to project our laser on this target. Also, we have to like this is the logic of a reflection of a laser. It's vector 2 into 2 projection into normal. Let me see first how it goes.
All right, so we're gonna assign our target in the wedge trigger. So we're just gonna hard code a single target. Or not something is inside or outside. All right, so we're gonna assign our target in the wedge trigger. So we're just gonna hard code a single target.
Yeah, okay.
We're not gonna write a whole targeting system. We're not gonna write.
I really like the hierarchy of hers, actually. Can I make that? And I can just make her hierarchy is so good. Inspector, console. Okay. Yeah, this is way better. Like I can control the inspector right here and the hierarchy over here and project settings are over here. So this is cool. And I can also see the console over here. That would be very useful.
And a whole targeting system. Okay.
Oh yeah, you're right.
Okay.
Also said this one. Okay, I have to see. Really not the complete piece. It's 0, 8, so default. Default equal to 0, 0, 0. So so Z will be 3. But anyways, this will be x, 0, 3 and yes, Control F and I want to origin origin, and I want to report the Forbes. Okay. This is fine. Not this one, right? Something right.
Okay. So now we need to make a function to check. I'll just delete this guy. We need a function to check if something is inside of this trigger or not. So I'm just going to call that contains. Bool contains. Oh, you got it working. Nice. Okay. Okay, we're gonna check if it contains some position or some target. I don't know what to call this one. Target's probably fine. Or wait, we're using that name here. Let's do position. Is 180 degrees the limit? I think it should be possible to go all the way to -1. I'm not sure if my...
Yeah. Quick fix.
Math has support for that? Maybe? You can try. Change the slider. Yep. So if you want one that is greater than Yep. You can try. Change the slider. Yep. So if you want one that is greater than 180 degrees, you can do that, but it's kind of ambiguous which side it's on. But in my case, I don't want it to ever go behind itself, so. Okay. So now we need to do the checks to see if it's inside or outside. And like I mentioned before, we basically have 3 different things that we're checking. We're checking a cylindrical radial check. We also have a height check. That's kind of the top and bottom planes that we're checking that were within that interval. And then we have an angular check. And so these are kind of the 3 conditions that have to be met in order for us to be inside or outside this thing. Okay. And so, I guess first we can just make a temporary function to make sure that it works. So maybe we can do vector3 dot distance between position and transform dot position, and if that's less than radius. So now this is just a spherical trigger, so just doing this temporarily. Just because I want to set up the coloring so that we can color the gizmos. So let's set the colors. We're also going to set the handle color. So contains target dot position, and if it does, we want to use color dot white. Otherwise, color dot red.
Yeah.
Okay. Let's try that. So now it should be a spherical trigger, which is incorrect, but just to make sure we get the coloring working. Okay, neat. That seems to be
Let's see. We can.
white.
We can.
Set the colors. Just because I want to set up the
Position. Comma. Position of my target. Transform dot position. Radius.
So, contains. Which is incorrect, but just to make sure we get the coloring working. Okay, neat. That seems to be working. But now we need to make sure that it actually does the correct check here. All right. So, one part of this assignment was that I wanted you to do this in, to make sure that you can still move this around and do all of this in, so that you can rotate the trigger and all of the checks should still work the way you intended. And again, this is a use case where if you do things in local space, all of this is going to be much, much easier. If you do this in world space, there's a lot of like projection and vector math that you have to do that is kind of annoying. And so one of the first things you're going to want to do to make this simple is to transform the direction to the target into local space. So instead of doing this in world space, if we just know the direction to the target in the local space of this transform, all of this is going to become much, much simpler. So let's do that. So first we need the direction to the target, right? Direction to target. So that is going to be the position is the target, and then transform dot position is the origin. This is kind of the vector from this object to the target. But we're also going to want to normalize that. Otherwise, it's just a difference vector or a displacement rather than a direction that's usually normalized. But this is in world space. But we want this in local space.
Then we have to matrices.
So direction to target. Like I mentioned before, Unity has built-in functions for this. And this type of transformation is basically doing the matrix multiplication we talked about earlier.
Vector 3.
So we want to convert this to local space, and we do that using transform dot inverse transform direction. You could also use inverse transform vector. The difference between those two is just how it handles scale. But we don't have any scaled objects right now. So in this case, we can just use inverse transform vector. And so in here, we just pass in our world space coordinate, and we're going to convert that to local space, because inverse transform is world to local.
Yeah.
Okay. So now we have the direction in local space. And that is wonderful. Actually, we're gonna need the full vector, so let's not normalize this.
Why?
And this is gonna be the vector to target. And then we can have the direction separately.
Oh, I see. This is vector to target. Let's not normalize it. This would be our target. normalize now. We have to normalize it better.
Okay. These are the things we're
Yeah. See?
gonna need. So let's start with the easiest one. So that's going to be the height position check. So if we have the location of the target here in local space, then if it's below 0, it's outside on the y-axis. And if the y-coordinate is above our height value, it's also outside, right? If it's of So if we have the location of the target here in local space, then if it's below 0, it's outside on the y-axis, and if the y-coordinate is above our height value, it's also outside, right? And so all we really need to do the height check is to check the y component of our target in the local space coordinates. And so that's all we need to do to check the heights. In other words, if the vector to target dot y is less than 0, or if the vector to target dot y is greater than height, then we return. Oh, we return false because it's outside, right?
Now we have to like see if the vector to target dot y, okay, is equal to is less than 0. Okay. Yeah, it's outside then. What the fuck? It's what? Give me a second. I think I need to restart it. Yeah. Ah, I see. Even green days. Y is less than 0. Or vector divided dot phi is greater than height
Okay, so if it's outside that, it is not inside. So we can just early out this function. We don't need to run all of the calculations. We can just skip the rest because if it's outside the height range, it's never going to be in calculations. We can just skip the rest because if it's outside the height range, it's never going to be inside this anyway. Okay, so let's test this. Okay, so this one, remember that we're just checking the height range now. We're not checking anything else. So we can see that it's outside here, inside, outside, inside, outside. It seems to be checking that height interval, right?
Inside. This is this. Inside, outside, inside, outside. Now I can make the radius radius trigger.
So that seems to be working. Even though it's rotated and all of that. So you can see that if we did this with world space coordinates instead, then this would look a little bit different, right? Then that would involve like using the dot product of like we would take the a lot more complicated or vector3 dot dot transform dot up between that vector. So then we would get the projected distance onto that vector using our relative vector there. And then we would check, then we would do the range check using this value instead of vector target dot y. So instead of just reading a single component, we would have to calculate this using the dot product, which is more expensive than simply just using the y component, right? Okay, I'm gonna go get my tea. Not working for some reason. Did I mistype something? Yes, your transform is using inverse transform point, but you have to use inverse transform vector. Because again, we're transforming a relative vector. We're not transforming a position. Because this is a relative vector, right? And then we want to transform that from world space to local space. Before 1.8, I feel like it like secretly normalizes stuff, but maybe we can see what it does, or maybe it's internal. Okay, yeah, it's internal. Maybe we can see what it does, or maybe it's internal. Okay, yeah, it's internal. Yeah, I don't use it because I feel like it's secretly calling normalize. I'm not sure if it does, and I forget how it deals with scale. This operation is unaffected by scale. Yeah, this is world to local, unaffected by scale. Okay, I don't know if it normalizes. It's a little unclear. I feel like it should normalize if it's called direction, but I don't know. I don't use it, and so yeah. I think vector takes in scale as a factor. Yes. Yeah, so I think if you pass in the question for me is, what happens if I pass in a non-normalized vector? Will this normalize it or will it not? It's a little unclear. I don't know which one it does. But generally, whenever I transform vectors, I almost never have scaled spaces. So for me, I just pretty much always use inverse transform vector or point, right? Okay, I should probably, hold on, I just need to pin a message because a lot of people are asking about that. Okay. Okay. All right. Next one. Next one, let's see, which one do we do? Let's do the wedge, because that one is actually very simple. So we want to do the angular check, right? But if we go back here, remember that if we have the direction to our object, then this length right here directly relates to our threshold value, right? And so if we have this direction, we can simply check the, in this case, the z component to see if it's above or below our threshold. And so we have direction to target here. I guess maybe we should move it down. So then all we need to do to check our threshold is if direction to target dot z, because that is the that's the forward direction of our trigger. So the blue one is the z-axis, and that's forward. So we just need to check if this one, if that one is less than our angular threshold, then we return false, because then it's outside the angular wedge. Our angular threshold. If that one is less than our angular threshold, then we return false, because then it's outside the angular wedge.
Easily look.
So we can comment out the height position check so we can test this one in isolation. Okay. So that one is inside and then outside. Inside, outside. Not sure if this doesn't look like it actually works. Something's wrong. Something's wrong. Outside. Not sure if this doesn't look like it actually works. Something's wrong. Something's wrong. Inside, outside. Not sure if this doesn't look like it actually works. Something's wrong. Something's wrong. Yes, okay. So one of the things that we need to keep in mind every time we normalize vectors like this, and when we're working with spaces that are not radial, because remember that this one is actually a cylinder, we're not working with spheres, right? And so when we check for this one, we actually need the normalized flattened vector. Because if it's pointing upwards in some sort of direction, it's going to start creating the shape of a sphere, right? Not a cylinder. And so when we normalize the 3D vector, it's going to become a little bit shorter up here. So I suspect that in our case, it's going to work if it's all the way down here, like near the bottom plane. So here, it seems to work fine, right? So inside, outside, inside, outside. But as soon as we move it upwards, now it no longer works because we're doing we're basically normalizing in the sphere. So we're gonna have to do a little bit of shenanigans here, where we're gonna need to flatten this one. So we actually want the direction flattened on the XZ plane. Okay, so let's do flat direction to target. So we're gonna set that to initially set that to the vector to the target, and then we do flat direction to target dot y equals 0. So we flatten it so that it's along the floor of this. Okay. Or maybe it's internal. Okay, yeah, it's internal. And not sure. So vectors like it's so we have on to flat direction to target dot y equals 0. So target. And then we normalize it. And then we can check that components. Okay. So recompile. Okay. Okay. So recompile. See if this works. Because we're doing the infinite wedge right now. We're not doing the... It's not getting clamped by the height. So now it seems like our inside-outside test is actually working. So it's in... Inside should be inside this plane. There you can see that it's here. Did that make sense? It's a little bit funky because we're flattening vectors and doing a vector 3. We could not doing an unnecessary addition and cubing, but yeah, did that make sense? People are typing. I didn't get how checking the Z counts as checking the angular threshold. Because our angular threshold is determined by setting this value, right? Like we decide what result of the dot product should be is the z-axis. Actually, our this axis here, and the z-axis here, and the y-axis is point. Yeah. And so we have the height basis check. We have the angular wedge. Okay. Finally, we need to check if the if we're outside of the cylinder. So now we're doing the height check. We're doing the wedge. So we can test the height. We can be inside or outside here. And we can be inside or outside the wedge, but it still counts as inside if we're over here, right? And that's incorrect. Like this should not count as inside. So the distance test is not working as is. So we need to do that. And again, here we need to be careful to use the flattened or the two-dimensional distance to make sure that it becomes a cylinder. If we don't do that, we're actually going to be testing a sphere, like a cut-off sphere, that would give us a little bit of extra distance. Again, none... None of these are like either correct or wrong. It just depends on how you want to design your turret. So maybe your turret is just supposed to work like that. So again, it kind of depends on like what type of trigger you want to make. But if we want to make this type of wedge, like a cylindrical cutoff, then we need to use a cylindrical check, which means that we're doing a we don't really use a 3D like spherical distance test. We're just testing the flattened 2D vector, and that turns it into a cylinder. So we're gonna make use of this flat direction again, but we kind of need the distance now. We don't actually know the length of this one, so we need to know how far away is the target along this flattened vector. So we need to calculate that. We're going to do that here. So this is kind of the flat distance. Let's just call it that. And that is going to be flat direction to target dot magnitude. And here we can actually do a tiny little bit of an optimization. So here we are normalizing the flattened vector here, right? But now we're actually calculating the distance twice. And we're calculating the distance here, and we are calculating it in here in order to normalize it. So we could actually do a tiny bit of optimization by normalizing it manually. We just divide it by its distance, or length in this case.
By the magnitude.
And then we get the normalized vector. Wait, why is this sad? Oh, convert to compound assignments. Well, I mean, I guess. So this will actually normalize.
Yeah. Because flat distance is the magnitude of flat direction dot target, and when we actually divide the flat direction to target by its magnitude, it gives us the normalized vector. So it's an optimization we can actually make. Yeah, but magnitude is always float. So what we have to do is
Okay, so now we've done a tiny optimization. Isn't that cute? So now we have the distance, and now we can check for that too. So if flat distance is I guess we can just return directly here, but we should keep the same structure. So flat distance is I guess we can just return directly here, but we should keep the same structure. So if flat distance is greater than the radius, then we return false. So this means we're outside.
wow, that's easy.
Infinite cylinder. Okay. And if we pass all of these tests, we're inside. All right. And that should do it. I believe that is all we need to check this wedge. Let's make sure it works. Just to make sure I'm not lying to you. Okay, so now it's outside the whole thing, and it's inside. And there we go. And that seems to work. And we can change some properties in this one. We can change the threshold to be way more narrow. Wait. Really? What the fuck? How did I manage to place the target exactly so that if I set this to 1, it counts as inside? I thought this would be like floating points mathematically impossible to do. Anyway, sorry. So we're testing the wedge. It seems to work fine, right? Okay.
Yeah, it's impossible. We actually did it. What the fuck? Then we can change the radius. So now it's outside, inside. We can change the height. Outside, inside. Seems to work. All right, we did it. We made the radial trigger, or our cheese wedge trigger. Okay. Any questions about this?
Something is wrong for me. Okay, let's go back to code. How'd you draw the wire disk? That is handles.draw wire disk. Your first line should not normalize. So this line right here, don't normalize this one. Because this is just the relative vector, it's not the direction in this case. I think that's what's wrong with your code. Everything else looks good. All right. I don't know how time passes so quickly. It's actually insane. Apparently we're up on our next break already. I don't get it. All right. Any other questions about our trigger? Did you fix the inside when angle says F1? I'm not sure if it's always when it's F1 or it might actually be the case. Like, am I just placing the target exactly? Like, this should be extremely hard. Like, as you can see, I'm not hitting inside. Oh wait, there we go. Boop. Found it. I probably wouldn't spend time to fix this because I don't know what the use case is for a turret with a with a completely flat vision. Lots of typing. Could use it as a laser grid. You would probably make a different type of trigger then. Like using this for that would be strange. Like if you want to do a laser grid, it would be sort of like checking the distance to a plane, and if that plane is less than something, right? So it'd be more like a planar trigger or just a box trigger. In an actual implementation of something like this, would you use a box shape collision? Oh, if you mean the completely flattened version, yes. Usually if you want to make like a planar trigger, you generally use boxes because boxes are fast. It's very, very cheap to use boxes for testing. Okay. Yeah, let's do another 10-minute break. We're resuming.
Thank you.
Resuming at 11:10. Okay, cool.
You should also take a 10-minute break then.
Oh, by the way, am I going too fast? Am I going too slow? Am I not showing the code enough? Am I going on too many tangents? I'm not sure if we think about the pacing, if I'm completely off or if it's okay. It's also kind of hard because sometimes different students require different pacing. But I do want to try to keep it open so you can like ask questions at any time and just let me know if something feels off or unclear. Too perfectly paced. Oh, thanks. You're getting top grades. You did. That was a compliment. Good pacing, the concepts are just hard to grasp. Yeah, the thing is that like, we are basically speedrunning a shitload of math that you do for several years in school. And so it is kind of hard to grasp all of this. And like, it's easier for me to do this because I've been doing this for so long now. But if you have never heard of the dot product and you're just learning about it now, then I can imagine it's pretty fast paced, right? But I think there's a lot of value in having like actual use cases for these concepts where like, I imagine like when I learned about the dot product in school, I don't even remember learning about it. That's how much I've forgotten. I just completely dropped that out of my mind because I didn't know what the point was, right? But I'm hoping that if there's a context, it's easier to remember because now it's like, oh, the dot product is actually a useful tool, right? And then I'm giving you this tool that I'm hoping is useful. The dot product has eluded me until now. Oh, neat. This math dude we had at my last job said it gives a magnitude. That is very misleading. Oh, someone in YouTube chat. Can you reflect race with the dot product? Yes, that was the second assignment. That was one of the first assignments after learning about the dot product. I think I put a link to the assignments in the description. If not, I can share them with you. That's not the share button. I think I put this link in the description of the YouTube video. So there you go. That's a link to all the lectures and all of the assignments. So there you go. Second assignment was to make a bouncing laser. Are you worked at a place where you're making educational interactive stuff and they got the dot product wrong? Fascinating. I guess if it's not like math education, it might be fine. If it's like, I don't know, educational content for like biology or whatever, then maybe you don't have to know about the dot product. But if it's math, then it's a little bit suspicious.
Mm-hmm.
Was for grade 10? I don't know how it is in Sweden. Yeah, I forget. This lecture is going on for another hour. We're currently on break. So we're gonna go in 5 minutes. We're gonna do 50 minutes of going through the assignments, and then after lunch, we are going to look into trigonometry. So trigonometry is starting in 2 hours. Yeah, trigonometry class in 2 hours. That's the plan. I'm gonna cut the stream during lunch, so it's gonna be a separate link. So be sure to like, comment, and subscribe, and hit the bell and all of that if you want to catch the next thing, or just set an alarm in 2 hours from now. Okay. What was your specialization during college? I never went to college, and so
What?
I don't know. I did go to Future Games though, so it's a like short vocational school that was like 2 years long. Specifically for, I went there for game design. I don't do a whole lot of game design these days, but yeah. Otherwise I'm educated just to high school. So you're a self-taught developer? I feel like the word self-taught is a little bit misleading because the thing is you learn a lot when you're at a workplace. And I feel like I've learned most of my stuff from, well, both from hobby projects, but also just from being at a workplace and doing work. Like, you learn so much when you're at in an actual project where you actually have to ship a product and go from A to B, right? So to some extent, yes, I guess I'm self-taught, but I learned a lot just through work and not just like, yeah, it's not like I've been doing all of this on my own. Are you from the UK? No, I'm not from the UK. I would have expected my accent to... Like, my accent is not very, you know, UK, but... But sure.
She has a big accent though.
Okay. More tutorials, less playing games? What? Buddy, I can do whatever I want on my YouTube channel. And if I want to play D&D with my friends and put videos about that on my YouTube channel, I'm gonna do that because I really enjoy that. I am not someone who's just gonna do whatever you tell me to do. Preebie. What a YouTube chatter. Classic YouTube chatter. I really enjoy that. D&D. Buddy, more tutorials, less playing games? Okay. More tutorials, less playing games? What? Buddy,
No.
I can do whatever I want on my YouTube channel. And if I want to play D&D with my friends
student
and
like
put videos
that
about
is,
that on my YouTube channel, I'm gonna do that because I really
such
enjoy
a
that.
pain
I
in
am
the
not
ass.
someone who's just gonna do whatever you tell me to do.
Nah,
Preebie.
true.
What a YouTube chatter. Classic YouTube chatter. If you ever worked on Unreal, yes, I have worked in Unreal. Mostly in Unreal Engine 3. I've done some work in 4, but mostly in 3. Are you mainly C# and Java developer? I used to do Java a long time ago. These days, I mostly do C# and HLSL. Most of what I do is in Unity, and I do mostly tool development and shader stuff, and a little bit of gameplay programming as well, depending on what I'm doing, and depending on the current project. So a lot of C#, a lot of HLSL. Yeah, that's kind of what I focus on. Sometimes when I have to, if I'm doing like online stuff, I obviously have to use HTML, JavaScript, PHP. I usually just do vanilla JS, for better or for worse. I'm uncomfortable with modern web dev, so modern web dev seems scary. I don't want to have to install 50 frameworks, and I don't know, so I just do vanilla. Draw furry art on stream just to piss people off. I did that a while back. I really need to get back into art. I really want to. Yeah, I think after my lectures at Future Games, and after I've released my
GLSI.
Spline video,
GLSI is actually a Unity programming language for the shaders. I mean, we can search for it. GLSI. Oh, it's GLSL, sorry. It's not GLSI, GLSL, yeah, this one. This is for Unity programming stuff. Programming shaders. It's for shaders, is actually. I have. You probably want to convert to HLS. Just Google result rate. HLSL. GLSL is a shading language for OpenGL and Wacom, while HLSL is for Microsoft DirectX. Okay, the key difference is the syntax. GLSL is C-like, HLSL is more like C++. Default matrices order. GLSS is column measure, slow measure, and its ecosystem. GLSL is cross-platform. HLSS is Windows, Xbox system. Ah, I see. GLSL is we can actually use GLSL for the even for the console games, and I think the Nintendo and mobile phone as well. But for HLSL, I think it's basically for the DirectX, Microsoft DirectX. So yeah, vector stack, vector 2, vector 3, vector 4 with precise log medium, right? Float 2, float 3, float 4.
I've been working on for a year. Oh god. I think I need to take a break because I've been like it's been a struggle because I got burnt out in the middle of the year. And so I think I need to step back from the type of work that I'm doing right now, like coding, I guess. So I think I'm probably gonna try to force myself not to do this type of work after my spline video is done and after my lectures. I think I'm gonna try to just do more art. I want to do more art, and I want to get better at it, and it's something I really enjoy. And so I think that's what I'm gonna do in a bit. In a few months, I suppose. I hope you'll stream that. If I do, I'm gonna stream it on Twitch, because Twitch has much more lax music copyright policies. Streaming on YouTube is a nightmare because I'm gonna get like copyright stricken immediately. Okay, all right. I think we should resume. I think the break is over.
Now we'll continue tomorrow. After this, we can do it tomorrow. Now we are almost over 2 hours now, so we can like continue it with the laser part tomorrow. We have done our the condition part, and now we can like do the laser part tomorrow. This is the quick method. I've noted it. Now I have to just make some notes and just I have to sleep because I have class tomorrow. So yeah. Thank you guys for today. I'll see you tomorrow then. Bye bye.